Good morning.
Morning, sir.
In a minute, we are going to start this session.
वो बता रहे क्या?
Any question, Sarfraz? Okay, guys. So let us start the next point. Okay. So that is the concept of projectile motion. So we will see what is projectile motion and what are the examples where we come across this projectile motion. Okay. So as you can see, projectile motion is the motion of an object thrown or projected into the air. Guys, mute yourself. Okay. So any object thrown or projected into the air. When you toss something in air or when you throw something like stone or if you play with balls, okay, when it is thrown into the air and such object is under the influence of gravity only. It is subjected to acceleration of gravity. You know that gravitational force will act on that object. Okay, so under such condition, whatever is the motion of object is called as projectile motion. The object which is thrown into the air is called a projectile. Is called a projectile, and its path is called its trajectory. So whatever path that particular object takes, okay, while reaching or dropping to its final destination, that particular path is called as trajectory, trajectory of the object. So what are the examples of projectile motion? You know that the bullets fired from the gun, once they leave the gun with some initial velocity, okay, where until it is in the air, it is subjected to the gravitational force which attracts it downward. Then slingshots, okay, generally you use it in order to aim something. You play it, baseball, rockets, all these are the examples of projectile motions. Okay, so see some of the examples like this. So this is the football which is kicked on the ground here. When you kick it, it gets thrown into the air with some velocity in this particular direction. Say that direction is alpha, angle alpha. Okay, so you can see it follows a particular path, is called as its trajectory. It is under the influence of gravity. Gravity will accelerate it here and also retard its motion. When it is going up, gravity will act downward, so its motion will get retarded, and finally after assuming certain maximum height, it will start its journey downwards towards the ground. Similarly, a case of the bullet fired from the gun or a cannon. Okay, so when you fire the bullet from the gun, initially what should happen that the bullet should travel in a straight line. But what happens that the gravitational force is also acting on this, so it will change its path to the one like a parabola, like this curve. So if your target is quite higher and higher, is far away, okay, so you have to properly take care of this. Similarly, you take the
So,
example of baseball. Yes.
so the bullet one, so the first it will go straight and then after some time it will come like a parabolic form. Na?
So when it is going straight initially, that time its downward movement is very negligible. You can say
Yeah,
you can say that. Okay, so the path will look almost like straight because it has so much velocity, initial velocity. Okay, so it also depends on that. This is the example of basketball. Okay, so we have to in this particular topic study the projectile motion. What are the equations applicable to this kind of motion, like that? Okay, so let's go towards that. Yes, so what are the important study points of projectile motion? What are the parameters in which you will be interested while studying the projectile motion. So one might be interested that at what velocity I fire the projectile. So definitely this parameter, initial velocity of the projectile, is going to affect the motion of the projectile. Okay. Then one will also be interested in what is the path traveled by a projectile, whether the projectile moves in a circular path, whether it moves in a straight line, or does it take the parabolic path. Okay, so we will see what is the actually the path of the projectile. We will prove it that it is a parabolic. We will prove it mathematically. Next,
Sir, wait. Sir,
yes,
should we write this?
no, right, just pay attention. So next is height. So it is also an important parameter that what height my projectile will assume. Okay, suppose if you want to achieve a maximum height of say 100 meter, then what should be my velocity? What should be my velocity? At what angle I should project so that I get maximum this horizontal distance? That how much horizontal distance is also important. Okay, so height is important. Time of flight. What is time of flight? That for how much time? For how much time the projectile, the object is into the air. So here it is leaving the ground origin point, and it is traveling it is traveling in a parabolic path and striking here. So it is a point of strike. So what time it is spent into the air, that is called as time of flight, is also important. Next is horizontal range. That what is the distance between point of projection, point O, and point of strike. So it is called as horizontal range. Um, so what is horizontal range of projectile? How I can maximize it with the given velocity like that? We will see. Yes, maximum horizontal range that can be obtained. Okay, if you are given a certain initial velocity. So we will also see that how we can maximize the range. Then we will also see one more point, that is two values of angle of projection for same horizontal range. You will find interestingly that there are two angles. Suppose this is the angle alpha. Okay, so in pair with alpha, there will be another angle, angle beta, which will give you the same rate, same horizontal range. Similarly, for angle alpha 1, in pair of angle alpha 1, there will be another angle beta 1, okay, which both will give you the same horizontal range. We will also see this point. Okay, so let us see one by one. First, we will see the path traveled by a projectile. Okay, so this point I want you to give more attention how I write the equation. So say uh, this is the projectile here, which leaves the point of projection. Point O is the point of projection, and here it strikes here at this point. So point S is called as point of strike. Okay, the you see here velocity has certain direction. Got it? That is U is the initial velocity. This velocity got the direction. It is not the object is not thrown vertically upward nor in horizontal direction, but the object is thrown with initial velocity u in direction alpha. This direction is measured from the horizontal direction, horizontal axis. Okay. Now it is, if I write down, if u is the direction in alpha, u is the velocity in alpha direction. Okay, I can find out what is the velocity of projectile in horizontal direction and what is its velocity in vertical direction. Okay, so you might remember that how we resolve the forces. So say u is the initial velocity and alpha is the angle of projection. Okay, so if you take the component of u in x direction, ux, so you will find, you know how to resolve the forces. Force is a vector. In similar way, velocity is also a vector. It has certain direction as well as the magnitude. So x component, its x component will be u cos alpha, u cos alpha. Okay. Then the vertical component of velocity. What is vertical component of velocity? It is the velocity with which the object is rising vertically upward. Okay, so uy will be given as u sin alpha. You got it?
Sir, can you repeat what alpha is the angle between what?
Angle is alpha is the angle of projection. Okay,
Okay, okay.
okay. So suppose if I throw the any object in this particular direction. Okay, so how you measure the alpha? Alpha is the angle of projection measured with horizontal. This is the alpha. In this direction, you throw the object. Okay. So now what is ux? Ux is the horizontal velocity of the object. This is the velocity with which the object is traveling in horizontal direction. इस direction में देखो, see, after some time what will happen, object will come here. Okay, initially it was here, so you can say that object has moved or traveled in x direction क्योंकि उसका x कोऑर्डिनेट चेंज हो गया है. देखो यहाँ पे कितना डिस्टेंस चेंज हुआ है. पहले उसका x कोऑर्डिनेट 0 था, लेकिन अब ऑब्जेक्ट का x कोऑर्डिनेट चेंज हुआ है, मीन्स उसका x डायरेक्शन में मूवमेंट हुआ है. ओके, मूवमेंट हुआ है मीन्स उसका x डायरेक्शन में कुछ ना कुछ वेलोसिटी था. So that we are calling as ux, which is the horizontal component of velocity u. Got it? Yes or no?
Yes.
Okay. So what happens in case of projectile motion? This horizontal component remains constant. It remains constant. Its velocity, this ux velocity will not change till point of strike. It will remain same horizontal direction because this velocity in horizontal direction is not affected by any other force. So not any other force means we are also neglecting the air friction. You know, air friction is always there. And what is the work of friction? Friction will oppose the motion. Friction will oppose the motion. Okay. But if it will oppose the motion, definitely velocity should go down. But what we are assuming that air friction is negligible. Air friction is negligible. That's why it will not affect the horizontal velocity. Okay. Now next, let us talk about the uy, that is component of velocity in vertical direction. Component of velocity in vertical direction. So it is the velocity with which the object is assuming height. Object is going upward because of this component, uy. Okay, but what happens that vertical component of projectile is not constant, it changes. अगर इनिशियली देखो, इनिशियली यू वाई का वैल्यू कुछ था यहाँ पर ओ पॉइंट पे, तो पी पॉइंट पे यू वाई का वैल्यू विल डेफिनेटली चेंज, लेकिन यू एक्स का वैल्यू विल नॉट चेंज. ओके, वाई? बिकॉज इन वर्टिकल डायरेक्शन कौन सा फोर्स एक्ट हो रहा है? विच फोर्स इज एक्टिंग इन वर्टिकल डायरेक्शन? यस, ग्रेविटी.
Gravitational pull.
ग्रेविटेशनल फोर्स. तो उस फोर्स की वजह से क्या हो रहा है, दैट ग्रेविटेशनल फोर्स विल अपोज द अपवर्ड मूविंग ऑब्जेक्ट. अपवर्ड मूविंग ऑब्जेक्ट को वो अपोज करेगा, उसको स्लो डाउन कर देगा. और एक पॉइंट ऐसे आएगा, यहाँ पे देखो, यहाँ पे उसका वेलोसिटी जीरो हो जाएगा. कौन सा वेलोसिटी? ये वाला, द कंपोनेंट विच इज मूविंग इट इन अपवर्ड डायरेक्शन, ये जीरो हो जाएगा यहाँ पे, इस पॉइंट पे. और जो ऑब्जेक्ट है, इट विल स्टार्ट कमिंग डाउन फ्रॉम हियर. ऐसे वो, क्योंकि ये जीरो हुआ और यू एक्स जीरो नहीं है, इट विल कंटिन्यू इट्स मोशन. व्हेन इट विल कम डाउन, इसका यू वाई कंपोनेंट फिर से बढ़ेगा, बिकॉज ग्रेविटी उसको खींचेगा यहाँ से. इट विल पुल इट डाउनवर्ड. सो अभी इसका वेलोसिटी बढ़ता जाएगा अभी. एंड व्हेन इट विल हिट द ग्राउंड, its vertical velocity will be at maximum value. Okay, so you remember these two things. Okay, now इसमें किसी को डाउट है कंपोनेंट्स में? Okay.
No, sir.
No, sir.
Okay, so here we are assuming that air friction is neglected. That's why horizontal component is constant. Okay, now let us talk about the path traveled by a projectile. So it can be understood if you have the equation of path. What is the equation of path? What is the equation of circle? Equation of circle is like this: x square plus y square plus radius का square.
R square.
So from the equation we can come to know that the path is either circle or a line or a parabola. So let us find out the equation of the path of the projectile. So let us find out the x coordinate. After certain time, the x coordinate of the projectile will change. Okay. So let us write the x coordinate. X coordinate is equal to so x is nothing but distance traveled by the projectile in horizontal direction. Okay, so distance traveled is equal to velocity in x direction multiplied by time. Okay, so velocity in x direction is equal to ux multiplied by the time. The value of ux is constant u cos alpha into t. So from here, the value of t can be taken as t is equal to x upon u cos alpha. Okay, say this equation is equation 1. So it is the x coordinate. Okay, now y coordinate. How to find out the y coordinate? You know that in vertical direction, in y direction, वेलोसिटी तो कांस्टेंट नहीं है, तो आप सिंपली ऐसे नहीं लिख सकते हो। वेलोसिटी अगर कांस्टेंट नहीं है तो आप ऐसे नहीं लिख सकते हो y इज इक्वल टू वेलोसिटी इन वर्टिकल डायरेक्शन इनटू टाइम। नो, बिकॉज ये कांस्टेंट नहीं है यहाँ पे, so this equation will not be applicable. So we will write down the equation of motion when there is uniform acceleration. Okay, so what is that equation? In that equation we find out distance as, I am writing the general equation. This u is not this u, correct? Please note down. General equation क्या है? S is equal to ut plus 1/2 at square. जब एक्सेलरेशन यूनिफॉर्म होता है तो ये इक्वेशन एप्लीकेबल है। 3 इक्वेशंस हमने देखा है जब एक्सेलरेशन यूनिफॉर्म होता है। So why we are telling that here in projectile motion acceleration is uniform? Because the projectile motion is subjected to gravitational acceleration g, which is uniform, which is constant. That's why equation of uniform acceleration will be applicable in this case also. So parallel to this, we will write down the equation in vertical direction. So what is distance is the what is the distance traveled in vertical direction? कितना है? Y है, y. It is what u is the initial velocity. So we will say what is initial velocity in vertical direction. हम vertical direction के लिए लिख रहे हैं initial velocity in vertical direction. So initial velocity यहाँ पे कितना velocity था? uy. Okay, so I will write down uy into time, okay, plus 1/2. Now what is the acceleration here? Acceleration is gravitational acceleration. Okay, as the projectile is going upward, the gravitational acceleration will be negative. It will oppose. Okay, क्या हो रहा है? जैसे जैसे प्रोजेक्टाइल अपवर्ड जा रहा है उसका वेलोसिटी कम हो रहा है, मीन्स उसका रिटार्डेशन हो रहा है. सो आई विल राइट डाउन माइनस जी. ओके, 1/2 माइनस जी इंटू टी स्क्वायर. ओके, ये समझ में आया आपके कैसे लिखा इक्वेशन? ये जो इक्वेशन है, इक्वेशन ऑफ यूनिफॉर्म मोशन, मैंने वर्टिकल डायरेक्शन में अप्लाई किया है. हियर वर्टिकल डायरेक्शन में अप्लाई किया है. सो वर्टिकल डायरेक्शन में अप्लाई किया है तो वर्टिकल डायरेक्शन का ही वेलोसिटी लिया है. ये क्या है? ये इनिशियल वेलोसिटी है. तो वर्टिकल डायरेक्शन में इनिशियल वेलोसिटी क्या था? ये यू वाई था. यू वाई ये इनिशियल वेलोसिटी है, और ये भी इनिशियल वेलोसिटी है, लेकिन ये कांस्टेंट ही रहता है. हॉरिजॉन्टल डायरेक्शन में वेलोसिटी कांस्टेंट ही रहता है. ओके, सो यू वाई टी प्लस 1/2 माइनस जी इंटू टी स्क्वायर. ये इक्वेशन समझा आपको?
Yes, sir. Yes, sir.
Okay, so let us write down further.
सर एक बार फिर से बताओ ना.
uh, ये how I applied this equation.
Yes sir.
तो ये जो इक्वेशन है, देखो ये इक्वेशन 3 इक्वेशंस होते हैं यूनिफॉर्म एक्सेलरेशन के, v इक्वल टू यू प्लस ए टी. देन दूसरा इक्वेशन कौन सा है, v स्क्वायर इज इक्वल टू यू स्क्वायर प्लस 2as. और थर्ड, s इज इक्वल टू यू टी प्लस 1/2 at square. This equation is applicable when the acceleration is constant. Acceleration constant है. So हमारे केस में भी acceleration constant है. That is g. And it is called as gravitational acceleration. Okay. So I have to apply it in vertical direction. Vertical direction के लिए apply किया मैंने. तो vertical direction में कितना distance travel हुआ है? Distance y. So this s की जगह मैंने y लिखा यहाँ पे. Is equal to, what is u? U is the initial velocity in that direction. So initial velocity in vertical direction. Vertical direction में initial velocity कितना था? uy. तो u की जगह uy लिखा, t plus 1/2. Now acceleration. Okay. So यहाँ पे projectile is moving up. So इसका जो velocity है, it is decreasing as it is moving up. It is decreasing. ये uy जो है वो कम हो रहा है. Means it is a retardation. ये अब जा रहा है और ग्रेविटेशनल फोर्स डाउनवर्ड एक्ट हो रहा है. तो ये जो है मोशन के अपोज में है. So that's why negative sign is given minus g into t का square. T का square. Got it?
Yes sir.
Okay. So now I will put the values here. What is the uy का value? Uy का value is this u sin alpha u sin alpha minus 1/2 u sin alpha के बाद t भी है multiplied by t. Okay, u sin alpha multiplied by t. t का वैल्यू क्या निकाला फ्रॉम इक्वेशन 1? फ्रॉम इक्वेशन 1 it is x upon u cos alpha. X upon u cos alpha plus minus 1/2 g again the value of t square. So t का वैल्यू इक्वेशन 1 से लिया, उसका वैल्यू आएगा x अपॉन u cos alpha का स्क्वायर. Okay, so you solve it. You can further write it like this. Y is equal to sin alpha upon cos alpha tan alpha, and this u will get cancelled. You will get cancelled. So you will get y is equal to x tan alpha minus this thing g into x square upon 2u square cos square alpha. Okay, so it is the equation of the path, of the projectile. Okay, if you compare it with the equation of parabola कैसे होता है? Y is equal to ax plus bx square plus constant if any So if you compare it with this, you can say that this path, this equation is a equation of the parabolic path, because this equation matches with this. Okay, so one can prove that the path of the or the trajectory path is known as trajectory of the projectile. So trajectory is parabolic of the projectile. Understood it? Yes.
Yes, sir.
Yes, sir.
Okay, so what you can do in okay, this I wanted you to draw this diagram, and write down this equation, and write down that it shows the path is parabolic. So you don't write it, I will share it with you. You just draw the diagram and this equation, say in 3 minutes. 3 minutes में आपको ये बनाना है, डायग्राम बनाना है और इक्वेशन लिखना है.
Sir,
Yes.
sir, that definition of time of flight, I have a doubt. That
Yes.
what is time of flight? It is the time where the particle reaches the highest point, no?
No, time of flight is the time the projectile or particle is in the air. It is still flying ना, it is still flying. यहाँ से maximum height तक पहुँचता है. It is still flying and then coming down to the ground. So time of flight is defined as the total time the particle is into the air and off the ground.
Okay, sir.
So, mute yourself, Sayed.
Done, sir.
Okay. Also, put your attendance in chat box writing division roll number and name. So let us continue. Okay, we have seen that path of the trajectory is parabolic. Okay, it is an equation of parabola. Okay, next interesting parameter, okay, to know is what we have seen, that is the what height it achieves. Okay, what height it achieves when you throw the projectile with velocity u and at an angle alpha. Okay, so that height can also be found, that height h, say this is the maximum point, this height you can find again by applying the equation of motion. So this is the distance. Okay, let us apply the motion equation. What is that? V, final velocity का square is equal to initial velocity का square plus 2 times acceleration and distance. Okay, so let us apply this equation in vertical direction में apply करना है. So what is the final velocity in vertical direction? देखो इस पॉइंट पे जो फाइनल वेलोसिटी है कितना हो जाएगा ये पॉइंट पे इन वर्टिकल डायरेक्शन?
0.
0. सो आई विल राइट डाउन 0 यहाँ पे. ओके, इट इज द इनिशियल वेलोसिटी in vertical direction. I'm applying this equation in vertical direction only, so no need of ux. Okay, so initial velocity in vertical direction, initial velocity in vertical direction is uy, which we have seen that uy. Okay, so I will first write it uy only, uy square plus 2 times acceleration due to gravity. So during this journey, when it reaches the height of h, maximum height from the ground, at that time gravitational acceleration is acting downward. Okay, so acceleration is nothing but gravitational acceleration, but it is acting downward, opposite to the motion. So I will give it minus sign. And what is the distance traveled in vertical direction? Distance traveled in vertical direction is h. So I will write down, in place of s, I will write down h. Okay.
Like, can you please say how you got v is equal to 0? That
Yes.
first, yeah.
Yes. So v is what? V is the final velocity. Okay, final velocity. So during this journey, when the projectile rises up from ground to its maximum point, okay, when it reaches the maximum point, there is its final velocity. So its final velocity is 0, because at this point इसके ऊपर तो वो नहीं जाएगा विथ, यहाँ पे वो यहाँ से जैसे पॉइंट ऑफ प्रोजेक्शन से स्टार्ट होगा उसको वेलोसिटी स्लो होकर यहाँ पे 0 हो जाएंगे इन वर्टिकल डायरेक्शन. हाँ, इन वर्टिकल डायरेक्शन. तो वो वर्टिकली मूव नहीं होगा, इट इज मूविंग ओनली हॉरिजॉन्टली एट दिस पॉइंट, क्योंकि उसका हॉरिजॉन्टल वेलोसिटी कांस्टेंट है. ओके, सो यहाँ पे फाइनल वेलोसिटी इन वर्टिकल डायरेक्शन 0 हो गया। समझ में आया?
Yes, sir.
हाँ सर।
करेक्ट। एंड यू वाई इज द इनिशियल वेलोसिटी इन वर्टिकल डायरेक्शन, जिसका हमने वैल्यू भी फाइंड आउट किया है। वैल्यू कितना है उसका? वैल्यू इज यू साइन अल्फा। यू साइन अल्फा उसका वैल्यू है यू वाई का, यहाँ पे फाइंड आउट किया था। ओके, देखो यू वाई का वैल्यू यू साइन अल्फा, इट इज द इनिशियल वेलोसिटी। हाँ, इनिशियल वेलोसिटी। So here I will
Sir,
write, yes,
sir, S can be Y also. No?
y is, yes, it can be y, but what is the maximum value of y is h, where
Yes,
we
yes,
are
yes. Got
yes,
it.
we are applying it here at this point. So minus 2 gh. Okay, so here we are interested to find out h. We will find out it. H is equal to, okay, just rearrange them. You will find out u square sin square alpha upon 2g. It is the expression of height, okay, maximum height achieved, okay, by a projectile when it is thrown into the air with velocity u at an angle alpha, at an angle alpha. So if your velocity is constant, और अगर आपने अल्फा चेंज किया, अल्फा अगर चेंज किया तो आपका जो मैक्सिमम हाइट अचीव्ड वो चेंज होगा। ओके, आप जितना उसको हॉरिजॉन्टली थ्रो करोगे विथ सेम वेलोसिटी, हाँ, विथ सेम वेलोसिटी, उतना ही ये हाइट कम होगा। व्हाट इज द मैक्सिमम हाइट रीच्ड बाय इट, और जितना आप वर्टिकली थ्रो करोगे उतना ही वो मैक्सिमम हाइट जाएगा, दो इट में इस रेंज में बी अफेक्टेड। सो यू गॉट इट, हाइट का फार्मूला कैसे आया?
Yes, sir.
यस सर।
सो यू राइट डाउन जस्ट फार्मूला हाइट, यू राइट डाउन जस्ट फार्मूला लिखो।
Sir, are these derivations are not important for exam?
Derivations may be asked, may not be asked, लेकिन अगर आप डेरिवेशन का प्रैक्टिस करते हो तो आपको फॉर्मूले ऑटोमेटिकली याद हो जाएंगे। यू विल मेमोराइज देम विदाउट एफर्ट्स, एंड इन एग्जाम even if you don't remember a formula, you know how to derive it, so you can confirm from it. Got it?
Yes, sir.
Yes, derivations आस्क होता है या नहीं होता है वो जाने दो, लेकिन आपको प्रैक्टिस करना है कि ये फार्मूला कहाँ से आया। ओके,
ओके सर।
डन।
Yes, sir.
Okay, so after height then comes the time of flight. Okay, ये what time it took, okay, to move from point O to point S. Point O is called as point of projection and S is called as point of strike. Okay, so let us find out the time of flight. Yes, time of flight we will see. So say t, time of flight. Okay. So first let us find what time it takes for reaching the height h. Okay. So obviously whatever time it will take to reach the height h, same time it will take for coming down from maximum height to on the ground. Okay. So let us find out the time taken by the projectile to reach the height h. Okay. So again we will be using an equation of the motion, that is final velocity is equal to initial velocity plus acceleration into time. So let us apply this equation in vertical direction. वर्टिकल डायरेक्शन में फिर से वर्टिकल ही डायरेक्शन में अप्लाई करेंगे. व्हाट इज फाइनल वेलोसिटी इन वर्टिकल डायरेक्शन? यहाँ पे इस पॉइंट पे 0 हो जाए फाइनल वेलोसिटी. सो आई विल राइट इट 0 is equal to initial velocity in vertical direction. Initial velocity in vertical direction is u sin alpha plus acceleration minus g time. So let us say this time is ta. ta is time taken by the projectile to move from the ground to maximum height. Okay, so you remember it is not time of flight, capital T is different.
It is time of ascent.
Yes,
Ascent,
yes,
descent.
yes, you can say time of ascent, you can say it. Okay, so from here I will find out ta is equal to, okay, it will be u sin alpha upon g, time of ascent. And whatever time it took for ascent, it will take the same time for descent, for coming down. Okay, so you can say that simply time of flight is nothing but double the time of ascent which you found. If you are uncomfortable for making time of ascent and descent equal, you can again apply this equation, okay, for downward motion. So for downward motion क्या होगा पता है? For downward motion आपका जो इनिशियल वेलोसिटी है वो 0 हो जाएगा. ओके, यहाँ पे आपको देन फाइनल वेलोसिटी आपको निकालना पड़ेगा पहले. जी ए का वैल्यू जी रहेगा एंड हियर इट विल बी टी. तो फाइनल वेलोसिटी आपको कोई अनदर इक्वेशन यूज करके निकालना होगा, दैट इज v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2s. उससे आपको निकालना पड़ेगा. Okay, so you will find that same expression you get even for descent. Okay, so here I will write down the time of flight. Time of flight is equal to 2 times this value. So 2 u sin alpha upon g. Okay, so this is your time of flight का formula. Got it?
Yes, sure.
Okay, so just write down the time of flight का formula. Done.
No, sir.
Yes, sir.
Okay.
Completed, sir.
Okay. So let us see the next important thing which we were to discuss after time of flight. It was horizontal range. So what is horizontal range? The distance, horizontal distance between point of projection and point of strike. ये calculate करना है हमें horizontal distance. So ultimately r is the distance in horizontal direction. So we will see what is the velocity in horizontal direction. Simple formula. What is velocity in horizontal direction multiplied by what time it takes for reaching the point S from point O. So that time we are calling as time of flight. And you know that Ux does not change. Ux is constant throughout this time. So we can appropriately use the formula distance is equal to velocity into time. So distance is our range. Horizontal range r is equal to velocity in horizontal direction multiplied by time of flight t. तो t का एक्सप्रेशन जस्ट ऑब्टेन किया हमने एंड ux द वेलोसिटी इन हॉरिजॉन्टल डायरेक्शन हमें पता है u cos अल्फा. Just take the multiplication and find out the formula for horizontal range. So it will be formula will be okay for horizontal range r. It will be equal to r is equal to velocity in x direction multiplied by time of flight. Okay, so velocity in x direction is u cos alpha, which is fairly constant. It does not change, okay, throughout its journey multiplied by time of flight. So r will be equal to u what is time of flight? 2 u sin alpha upon g. 2 u sin alpha upon g. Put this value here. U cos alpha into 2u sin alpha upon g. Okay, so it will become, you know what is this formula? 2 sin alpha into cos alpha. ये
Sin to
form
theta.
sin 2 theta. So you can put that r is equal to u का square multiplied by sin 2 alpha upon g. It is the formula for horizontal range. It is the formula for horizontal range. Okay, so two more points are there which need to be discussed. We will discuss it in next class. We'll solve some problem on it. Then this topic we will finish. Horizontal range. Any doubt? Anyone?
No, sir.
Okay. I will share it with you, this PDF, right after the class.
Sir, are you going to put this on Moodle as well?
I will put it there
Okay.
also. Okay, so I am stopping now.
Thank you, sir.
Welcome.